speaker, I would like to welcome Hoang. Happy to have you here with us. And Hoang comes from 3HLE, and he is going to talk about deep learning automatic vision, a novel high-resolution, fast and flexible software. So
yes.
The floor is yours. Thank you.
Thank you for introducing. My name is Hoang. I'm the founder of the company 3HLE Automations and Robotics in Switzerland. So we are now talking more about the applications and not how to train or how to do. So our objective is to make it easy to use for industrial and for engineers in industrial. So in these presentations, I will show a little bit how and where we can use it. So in Switzerland, everybody knows that the famous brands of luxury watches or other kind of watches are still very complex to inspect. Even if the parts that are hidden behind other mechanical parts are never dismounted or whatever, but they would like to make sure 100% that all the parts are scratch-free, no dust, nothing, even if you have very passionate collectors who would like to unmount completely the watch. So that's why all the parts are inspected manually and with operators. So our objective is to bring the machine learning and the deep learning inside those kind of applications where we can replace the human. Because in Switzerland, the average salary it's quite high, let's say one of the highest in the world. So if we would like to keep it competitive and to continue to produce in Switzerland, we need to use techniques that replace human or human-like behavior. So in Switzerland, it's also very known for most of the medical devices manufacturer. And in here, I will show you later on a few videos where we are doing as well. And sometimes people are just surprised to know, okay, Nestlé, it's from Switzerland, because it looks like it's a multinational company from America or whatever. So it's also a huge group that have producing chocolate and cheese and other derivative product based on the milk and the cacao, as well as coffee and food and beverage industry. So that's why we would like to improve the product quality to have the Swiss quality standards, to speed up the inspections, but using the flexibility of a human. So when I show this kind of, let's say, sketch, everybody knows what it means. So to summarize our deep learning algorithms, it's doing similarly to the human. So we try to remove all the useless feature and keep only a few characteristics to be able to detect object or as well defect. So why we can detect that? Because the human, we can assimilate a lot of pictures, and we can train ourselves without knowing it to extract only features that are necessary to recognize a house. And I don't want to lose the time to explain, but in mathematics, it's like we have pictures of 25 by 25 pixels. We try to reduce the dimensions down to, for example, in here, it's just like classifying to 10 class. Instead of 625 pixels, each pixel could be a class. So we reduce the dimension to make it lower dimension and to be fast. And what the industry is needing, usually, according to my long experience in the industry, we usually use the machine vision for security and traceability. So that means packaging and integrity, labeling, OCR reading, codes, and as well for pick and place part, because we need to assemble it with using robotics. And as well, most of what we do in here is to make the quality inspections, aesthetics, visual quality, to replace the human. So what we can use the deep learning in which kind of industry? So in Switzerland, it's not very known. People know more about chocolate and cheese, but we do also parts for automotive industry. So from A to Z, like the electronics, because we provide as well electronics components for sensors and things like that. So it's It's used by a wide range of applications. And why AI? So because the AI can bring to the market very quickly applications, and we can help the human to design. So as a former engineer doing everyday vision, machine vision with conventional vision, I used to spend like weeks to design and to test and to do machine vision inspections. And that's why with that experience, I bring it to the machine learning and deep learning to reduce the time of development so that we don't need to spend weeks to fine-tune one part. And during the productions, at the night times, the humidity is different, or the daytime is different, the winter is different, the summer is different, and we need to refine-tune permanently. So the machine vision allows us to be very flexible, to adapt to all conditions. So, and in our case, we use machine learning combined with conventional vision to optimize all the applications. So these kind of applications as well, this is a jar where we need to detect the defect that's cracked that looks like white on black, but there's also shiny characteristic on the jar that can look like a defect. But in here, a human can recognize quickly what it's a defect in here. As well for the medical devices, like this is an implant screw, where we need to detect a defect at on the threads. So the part need to rotate around, and human need to inspect. So we replace the human with one camera and rotate the part to inspect. So in here we see that there are some metallic part that's going in the threads during processing, and this is very tricky for the conventional machine to inspect. And in here we have as well some OCR tools to be able to detect on high-speed applications where we can produce up to 100,000 bottles per hour for water. But in the same line, production line, we have as well iced tea or other cola and things like that. So we can provide the machine learning to adapt to all these cases, to read the character even if the contrast is very low, even if the bottle is shaking and there's a lot of foam behind the scene. And this video shows how our tool can work it quickly within, let's say, minutes to design an applications for the, let's say, OCR reading. So you can see in here, sometimes it's just like iced tea that is yellowish, the color of the water is different. And sometimes it's just like foamy like this. I will go quickly due to the fact that we lack a little bit some times. So in here as well, for illustrations, we have watches where we need to detect this very tiny scratch on the glass. So it's very shiny part. And as well, we need to detect the scratches on the metallic part. So it's not only on the surface, but also on the component inside. But this video will show you more how the deep learning can be used to simulate the human behavior. So in here, we put cameras on the robot arms that simulate the head of the humans who inspect the part. And in here we can show as well how we reduce the quantity of work for the engineer to design an application. So with our software, we can simply acquire images and draw on the images and click on the training. So we optimize the software to be able to run on a GPU as well as on Jetson NVIDIA. It's a lightweight platforms. So for applications that need just 20 milliseconds for analyzing an image of 2 megapixels, we need to optimize that. And in our company, we try to optimize everything to do the best to reply to all customer needs. So I see that I'm running a little bit out of time.
Yes.
But this is how we use the deep learning in the industry. So thanks for following.
Thank you. Thank you, Mr. Lee. Thank you, Mr. Lee.
Thank you.